So welcome to module number 5. We have passed the quarter of the class, moving on to the second quarter. Time is flying. As always for this class, a picture for the week. And now this module focuses on network-based attacks and how they function in a very high level. Your lab will deal with more in-depth analysis. Actually, it's one of my more favorite labs to do in the class. So, networking-based attacks, beginning with interception, with the most infamous of them all, the man in the middle. It involves an attacker inserting themselves into a conversation between two parties. The actor will impersonate both parties to gain access to the information being sent, and neither legitimate party is aware of this happening. The tool of choice for many for this is EtherCap, usually done in a local network. They will simulate an access point or simulate the switch or the router and get the victim systems to connect to them, and through them pass packets on. It's not that hard to deploy in v4 networks. v6 a little bit harder because IPv6 doesn't use ARP, but it is much easier to deploy in v4 networks. There is, of course, man in the browser. And honestly, anything that is listening in between two legitimates will be a man in the and then whatever. So like man in the middle, man in the browser, man in the network, there's all kinds of those. So just understand that the man in the section is just intercepting. So for example, man in the browser is exactly that. The attacker intercepts and manipulates communication between a browser and the security mechanism of the computer. For example, through a Trojan browser extension, through any add-ons, or through forcing the browser to use a more insecure format like HTTP. Man in the middle resides exclusively in the browser, and that may make it hard for standard antiviruses to detect. It also means that there is a big emphasis on browsers because a lot of things are occurring through them. Since we use a lot of services now through these browsers, they are a program that you as security professionals should be keenly aware of. A replay is a variation on the man in the middle. Replay attacks will make a copy of a legitimate transmission, like a packet, before sending it to the recipient, sending it at a later time. A simple replay would involve capturing logon credentials between a computer and a server. When the session ends, the replay would be used to log on. Although cryptography can be used to thwart a replay attack, there are many instances in which cryptographic communications can be manipulated. An attacker could capture an administrative message sent from an approved network device to a server and use that to breach a service. Replays can be prevented with random keys, valid for a limited amount of time, using timestamps in all messages, and other methods. So for example, Windows falls prey to this because, like we saw the other week, it is very easy to replicate a Windows password. So if you can grab the hash, you grab that message being sent, it is a piece of cake to save it and resend it on the network later. And as long as the Windows server doesn't think anything's different, then it'll easily approve and let it go on. Don't you love Windows? Another type of network-based attack is poisoning. Starting with the old ARP spoofing. Like I said, the tool EtherCap does this just fine, where it will start telling other devices on the network, I am this IP address and this is the MAC address for it, in order to trick other systems on the network to update their tables and start sending traffic another way. So instead of it going, for example, from A to B, as it should, the attacker will modify both the ARP tables through just flooding the network until they update, and then they'll start sending traffic through the attacker. Now, ARP attacks can be fixed by rebooting the system because ARP tables are stored in RAM. So if you ever think your local network may be compromised and your data is being sent another way because your ARP table was poisoned, just restart. That'll clear the table. DNS is another poisoning. It substitutes fraudulent IP addresses from the symbolic names. DNS poisoning can occur in two locations: locally, in the host table, or on a DNS server. Every single device that connects to a network has to have a host file, which in anything Unix related will be an etc host. For anything Windows related will be in the Windows folder, System32, drivers, etc, and then there'll be the host folder. You have to be a super user to change that file. External DNS works not by attempting to break into the system, but exploiting a protocol flaw and convince the authentic DNS servers to accept fraudulent entries. If the DNS server does not validate those entries, it'll store them and then distribute them out to legitimate users, thus poisoning not only itself, but also poisoning all the other devices on the network. Sadly, a lot of DNS systems aren't built to be secure, so they'll accept fraudulent connections, fraudulent records, and spew those out to legitimate users and cause mayhem everywhere. Another is privilege escalation. This attack exploits vulnerabilities in software to gain access to resources that a user normally would be restricted from accessing. One type of this is the vertical privilege escalation, which you see here. If a malicious person logs in as a user or a service user, they will do their best to work their way up to NT authority or to root and gain full access to the entire system. There's also horizontal privilege escalation, where if one user doesn't work, maybe I'll try another user, and maybe through that user, I'll gain enough privileges to work my way up. This happens with systems that share resources, allowing an attacker to move from one system to another until they find a way to escalate vertically. One common way of attacking a server is through denial of service. Denial of service is really an annoyance. I tend to do this whenever I do career days at elementary schools, where I'll ask for two students from the group to stand up in front of the class. And then I have the entire class tell the two students who are standing with me 3 sentences at the same time. And the 2 students who are standing there with me have to capture as many sentences and say them back once everybody is done saying their 3 sentences. Now, kids being kids, they understand that they want their sentence to be the one remembered and said back. So, it takes a split second for them to realize I need to be louder than everybody else in the class so that my sentences are heard. and it just becomes one big loud noise for a good couple seconds as all the kids try to yell their sentence above all everyone else. And the poor kids who stand in the front just take the full brunt of this. And then when I ask them, well, what did you hear? They typically say nothing, or they'll or they'll say whatever was the very last sentence spoken after everybody else spoke. That is basically denial of service. It's just an overwhelming of high volume of bogus requests that a system just can't respond to legitimate requests as it's trying to process the overwhelming high volume. There are some subcategories of DOS, like Smurf, where attackers broadcast a network request to multiple computers, but changes the address from which the request came to the victim's computer, making it appear as if it's asking for a response. Each of the computers then sends a response to the victim's computer so that it's quickly overwhelmed. There is the amplification. Like Smurf, this attack floods an unsuspecting victim by redirecting valid responses to it by using publicly accessible and open DNS servers to flood a system with DNS response traffic. There is also SYN flood. Attacker sends a SYN segment or SYN packets to the server, but modifies the source address of each packet to a computer address that does not exist or cannot be reached. The server continues to keep these sessions open and wait for a never coming response until it runs out of resources to respond to legitimate requests. Again, a DOS attack is just an annoyance. Legitimate users can't get through because all of the lines are busy. Hey, you know what's another DOS attack is everybody trying to get a vaccine and waiting on the phone line forever or waiting on sites who are being overwhelmed. Moving on, we're going to spend most of our time this week on web server application attacks. This one is an example of the cross-site scripting, or XSS. Attackers take advantage of web applications that accept user input without validating it before presenting it back to the user. Attackers can trick valid websites into feeding malicious script into the web browser, which will be executed. There's also the cross-site request forgery, or XSRF. This attack uses the browser settings to impersonate the user. By tricking the user who is already authenticated on a website to load another web page, the new page will inherit the identity and privileges of the victim to perform an undesired function on the attacker's behalf. There is also SQL injection, or as it's known, SQL This is the number one type of attack, the number one issue with web server applications. The two that I just covered before are number 7. This is number 1 on the list. This attack inserts statements to manipulate a database server. SQL introduces malicious commands for the server to run. You will be playing with SQL this week. We also have things like hijacking, session hijacking, which an attacker attempts to impersonate a user via stolen session token. There's URL hijacking. Attackers purchase domains that are spelled similarly to actual sites in hopes that a user will mistype and go to their site. Domain hijacking, using domain pointers that link a domain name to a specific web server changed by an attacker. And clickjacking, users tricked into clicking a link that is other than what it appears to be. Adding on to the more ways things can get attacked, buffer overflow. a process that attempts to store data in RAM beyond the boundaries of a fixed length storage buffer. Because running programs as buffer have a return address set, a buffer overflow can take that spot and run malicious code. For example, spewing out all the users that are logged in, or being able to read RAM and dump information. Browsers. Now browsers. Because they are so highly utilized now, there has to be a lot more focus on them. And currently, we honestly have three browsers. We have Chrome and all of its family. We have Firefox and we have Safari. Those are the three main browsers because everybody else comes from them. So, for example, Brave comes from Chrome, Opera comes from Chrome, um, Chromium, Chrome. Those spawn from that. Firefox has things like Iceweasel and Tor, and well, Safari. But these are really the three browsers that exist, and everybody else uses their platforms, their engines to create whatever else they want to add. So it's important to make sure that these browsers are up to date, that these browsers are doing what they should, because it's very easy to run things like extensions and plugins and add-ons that could end up hurting them, like running code that they shouldn't, and thus being a vector for attack and successful infiltration of a network. Are there any questions? Looking around. Okay.